Welcome back. New research is out on groundbreaking living robots that the University of Vermont has developed in partnership with Tufts University and others. These Xenobots are made of frog stem cells and were unveiled by researchers back in 2020. We first told you about them yesterday, first at 4, how they are now reproducing in a way that's never been seen before. And here to break down those findings in more detail for us is Sam Kriegman, one of the Xenobot researchers who's graduated from UVM. Thank you for being here again to talk about these.
Thanks for having me on the program, Kat.
So let's start with the new research. We've talked to you about these before and how they can move, they can heal, and now these Xenobots can apparently reproduce. Describe briefly for us how that works.
Yes, so the Xenobots are, in a nutshell, robots made out of cells instead of metal and plastics and electronics. One thing they can do is self-heal, which we talked about before. If you cut them in half, they zipper themselves back up. Another thing that we're showing in this new paper is that because they're made out of cells, they can make copies of themselves, they can replicate, but it's in a unique way. So the Xenobots are able to build other Xenobots. And this is something that is very exciting and has been a dream of roboticists since the very first autonomous robots were being built all the way back in the 1940s.
How did you figure this out?
At first, we realized in one of the previous studies that the Xenobots were good at making piles. They could be designed so that they act like tiny little bulldozers in their dish, and they would push other particles in their dish, whatever they were, into piles. And then my colleague, Doug Blackiston at Tufts University, had the genius idea of replacing those particles with other cells. And the Xenobots move around these cells in the dish and push them into piles. And those piles of cells, after a few days, they compact into a sphere. They grow little cilia hair, which acts as tiny little oars on their surface and allows them to swim. And then those little swimming children that were just made can also build piles, which become their grandchildren, and so on.
Got to pause for a moment here and say I've seen a lot of sci-fi movies, and the idea of robots creating more robots is, the plot of several of them, not in a great way. Is there any concern ethically about this?
So the Xenobots are extremely simple. It's important to remember that these are tiny little specks, no bigger than a poppy seed. And the system is very fragile. They're swimming around in a petri dish, and if you sneeze in the dish, the experiment's over. If you shake the table, the experiment's over, they stop replicating. The conditions have to be very specific in order for this to happen, and we have to keep giving them more cells to be able to build out of. And even under all of those perfect conditions, replication still stops after a few generations. So I think that this safe system and this very simple system is more like a scientific tool at the moment. It's going to help us learn about self-replication, which is this very fundamental property of life, and maybe in the future be able to build useful self-replicating technologies. And when we get to that point, we can decide whether or not, if at all, we want to unleash them into the environment.
So do you have a practical application for these yet, or is that like years off?
Oh yeah, that's years off. But because they're biodegradable, they might have future applications in environmental cleanup jobs. So you can imagine unleashing these into the ocean so that instead of corralling other cells or other particles, they are corralling microplastics in the ocean. We're not really sure if the Xenobots will ever be useful technology, but they're already a useful scientific tool. We're understanding what it takes to build robots that can operate in the wild.
What's next for your Xenobot research?
Well, we want the Xenobots to be a little bit more intelligent. Right now, they're moving around essentially with no eyes. So we want to create better robots out of cells. And one other thing we'd like to do is we would like to use the Xenobots to understand biology better. And if we could understand more about how cells build complex bodies, we might be able to control this better, and this might lead to regenerative medicine or being able to stop cancerous growth. So there's a lot of potential here that we could learn from the Xenobots, and that's something that we're very excited about in the future.
Well, keep us posted as you learn more. It is fascinating. Sam, thank you for taking the time to talk with us, as always.
Thank you.